Alright folks, welcome back. In this video I'm going to show you how to identify functional groups. We're going to be looking at two different handouts today, and if you're wondering where I got these handouts from, I'll show you on my website in the chemistry section. Notice I'm at whittlehigh.com/jcantrell/chemistry.html. Anyway, this is one of the last topics in Unit 4. And the two handouts that we're going to be looking at is handout 7 and handout 8. Okay. Now both handouts will show you what functional groups that you have to memorize. For my high school students, unless they're in an honors class, I do not have them to memorize it. If it's the general class, I usually let them use their sheet. Honors class, no. Okay. Anyway, let's just go over some things really quickly about what these things are, maybe some helpful ways to identify them. Okay, an alkane, basically everything has all single bonds. An alkene is basically you have one when you have a double bond. An alkyne is when you have a triple bond. An alcohol has a hydroxyl group, this OH that you see here. This R is to represent any carbon chain. Now thiol, notice that anytime you see thio, THIO, that is always going to be some type of sulfur. So what you need to remember is with thiol is just basically if you see a sulfur, SH, but I want you to be leery, just basically this, if you see sulfur, automatically call it a thiol. Now ether, I love ethers because ethers and esters are probably the two best to memorize. Now let me show you why. An ether is basically surrounded by two separate carbon chains. Remember, that's what R stands for. Notice here you have this carbon is attached to this oxygen. This carbon is also attached to the same oxygen. So basically, you have carbon chains on the left and the right, and it only has one O. So ether, one O. Ether O, either, ether O. Either O. Here, let's go down here and look at ester. Notice that these are the only two functional groups that you see that has the letter E in it. So basically the way that I forced myself to remember this was basically this E has an S. So I think of an ester as being plural, meaning more than one. Now let me tell you why I'm saying more than one. Notice that this and this is an O. It's got two O's. Two O's. So I just remember that an ester has two O's. Now the reason why I emphasize that is this. You still have the carbon chains on the left and on the right. Okay? Now, here's your two O's. But what you got to remember is that one of these O's, this one right here, is double bonded. This other O is not double bonded. So can you see the similarities between an ether and an ester? Both have an O in common, meaning they have O's. But this one only has one O. This ether does. Okay. Anyway, that's the way that I always remembered ether and ester. Ester is the plural, meaning more than one oxygen. Ether is just one oxygen. Anyway, let's look at amine. Now, I love amines and I love amides. Now, let me tell you why. Amines and amides I always think of as nitrogen. Ammonia. Amine, amide. Ammon, A-M. Ammonia has that. So we know that ammonia is NH3. Well, notice here for amine that it has the word mine in the word amine. Now notice here that you have a nitrogen. This nitrogen is basically, if you want to look at it, is staking a claim on its carbon chain saying it is mine, all mine. Okay. Now I want you to also realize this NH2 that you see here, it can be N, just N, okay, and it could be NH, or it could be NH2. So basically what you need to really focus on is basically the nitrogen. Notice that this nitrogen is staking a claim on the carbon chain and saying it's all mine. So that's the way that I remember an amine is one nitrogen. Okay, and it's okay that it's got one hydrogen or even two hydrogens. That's okay, or no hydrogens. I mean, because that's possible, because it could have a lone pair. So just remember that, okay? Amine is one nitrogen staking a claim, saying it's all mine, because this nitrogen does not have to share that carbon chain. Now, check out amide. Amide has to admit that it's sharing its carbon chain with an oxygen here. Now notice that it is sharing this carbon chain that's over here with nitrogen. This nitrogen is sharing it with this oxygen. So it has to admit to sharing something. This nitrogen does. Admit, amine, is mine. One nitrogen is taking a claim. Amide has to admit that it's sharing its carbon and carbon chains with an O. Okay. Anyway, an aldehyde. There's honestly not an easy way to remember an aldehyde. I just think of an aldehyde as being basically a rejected carboxylic acid. Let me show you what I'm talking about. Notice that on an aldehyde and on a carboxylic acid, they both have the double bonded O. But notice that an aldehyde only has the only has the hydrogen. Now, the way that I always remember that was it has a hide. It has only a hydrogen, a hide. It's hide. If you also want to think of hide here, meaning to hide that oxygen, I guess that's okay. I'm just teaching you a way of remembering these. Okay, so aldehyde is basically a double bonded O and an H. Now, carboxylic acid, again, is basically, notice you've got the double bonded O, but it also has this hydroxyl group with it. Okay, so you always look at the central atom and look for your carbon chains when you're trying to help identify some of these. Now look at the ketone. Now the way that I remember ketone sounds like the word key. It almost sounds the same, And if you look at this, maybe you could envision this being a keyhole on the ketone. Okay, but notice that both to the left and to the right, you have a carbon chain, some type of carbon chain. Okay, even if it's just one carbon, still a carbon chain. Now we already went over carboxylic acid, and we went over about aldehyde being basically a shunned or or a beat up carboxylic acid because it's missing an O. Anyway, the other one we went over Ester. I can't remember how to pronounce this one. The like cyanide, so cyano. The way that I remember it is this just got cyanide on it. Okay, I don't see that often, but maybe some of you will in organic chemistry. But this is awesome to go that someone's actually explained this to you, because it's always helpful to have some gimmick of remembering these functional groups, and that's what I'm trying to do with you here. Okay, just go over a helpful way to memorize and to learn your functional groups. They have chloro. Basically you can tell that's a chlorine. If they ever give you something like a bromo, then I guess that's a bromine. Okay, don't worry about it. Anyway, a phosphate, I guess it's kind of obvious. It's going to look really weird. Okay, you're basically going to have a phosphorus that's going to be surrounded by oxygens. Okay, notice you're going to focus on that. It's got 4 oxygens surrounding the phosphate. Okay, kind of like the phosphorus here is already, its fate has been sealed in by 4 O's. We're out to get you. Okay, but anyway, that's the way that I bothered to teach myself to memorize these. That way I could actually keep them in my head, and it has helped over the years. This video's went kind of long, so since I've broken down a helpful way of remembering your functional groups, maybe now in the next video we'll actually go over how to locate them, and also which ones are going to be soluble in water and which ones are not. So anyway, next time guys, so check out the other videos and we'll actually show you how to identify them. Alright, hope it helps.